Now we want to examine a very basic and simple mill process sheet. So once again, I've said this is my connecting shaft. I'm working with operation 20, that I'm going to work on an Okuma 3-axis CNC mill. Reference my drawing number and my stock, and in this case, the part 0 may not be as obvious. So I've added a screenshot showing where the Z0 is, this face, and that my X and Y0 is the center of the part. Next, I've added the screenshot that shows the details of everything that needs to be machined. Nothing from the previous operation is dimensioned. I could add it if I wanted it as a reference. I've shown the datums, and I've shown the dimension of every feature which will be machined and any relevant GD&T for this part. So next, like any process, I want to stop and I think, well, how do I make everything? What operation is dependent on the next? So if we focus just on these holes could be made before we machine this face to size. However, if we do that, we're just going to push a heavy burr down into the hole. Again, this hole could be made before this face is machined, or this face could be machined and then this hole. These are independent. Machining around the outside profile here is independent of machining any of the holes or even this feature. But we want to consider our process, how we leave a burr. Does it get pushed over? Does it get removed? Is it more work later to deburr the part? So the first thing I want to do, I've decided I'm going to get a rough milling tool. It's shown here, a high-speed steel end mill. I'm being quite cheap. Can't afford carbide in my shop. And with that end mill, I'm going to machine this profile. And I'm going to machine these bosses here. I can also machine this face with it if I choose, or I could go to a larger face milling cutter, which would be quicker. So in this case, I will leave this for a face mill. I'll machine this profile and these here. So I've said this is operation 20.1. I'm going to use a 5/8 end mill. It's 4 flute and it's a regular length HCSO, so high speed steel cobalt roughing end mill, and I've included my pitcher. So what I would like to explain now is, how did I determine a 5/8 end mill would work for this part? What influenced my decision? Well, there's several factors which influence my decision. I'm going to machine this outside profile, so this internal radius will definitely influence the finished turning tool. So this radius is a 1/4 inch. This internal radius is the important one. The external one, not so much. That's going to determine the maximum tool size for the finish. So if that radius is a 1/4 inch, the maximum tool size or end mill I could use to machine this profile is 1/2 inch. But I would like to go smaller. Now the reason I'd like to go smaller than a 1/2 inch is I don't want the cutter to hesitate here and start to chatter. But the 5/8 will work, and I want to keep in mind, if I'm using a 5/8, well, that's going to leave extra material here in these internal radiuses, and I'll have to deal with that with the finished tool and programming it. The next thing influencing my process here is I need to be able to get past this 2.5 inches. The bottom of my end mill, when I go around, I would be machining around this profile in this view on my vertical CNC machine. But I need to be able to get it past 2.5 inches, and I need to consider the flute length. I need a minimum 3/4 flute length to cut this in one pass. This isn't very large, but this up here is 1.25 inches. So again, I would like to do it in one pass, not step down, but just one depth cut for roughing, meaning I need minimum 1.25 inches of flute length. So next, I want to bring in the window. So here's the window of our tool supplier. We work with SOA. They're great to us. And here's a picture of my cutting tool. So now, what am I curious about? I need to know the flute length and the overall length of the cutter, because again, I have to be able to get past that 2.5 inches, and I need 1.25 inches of flute length. So the first thing I'm going to do is I'm going to scroll down here, and I see if I use a 1/2 inch cutter, I do have 1.25 inches of flute length. So that's why I stepped up to the 5/8. So I have 1 5/8 inches of flute length. I have an overall length of 3 3/4. I'm just going to minimize this for a second. So if I come back here, 3 3/4, and all I'm really concerned is I can get past this. So if I have 2 3/4 extending beyond my end mill holder, so that would leave a 1/4 inch gap from this edge to the end mill holder, so I shouldn't hit here, and I can still hold on roughly an inch of the tool. So this tool should work for my purpose, and that's how I decided on what tool to do. I have to always take into account what do I have to avoid, what will be machined. And just like any process sheet, I have to now calculate the RPM, the feed, and describe the process. In the next video, we're going to look at more detail, just as a reminder of how I calculate the RPM and how you should calculate your RPM. And we're going to look at the recommended feed, and I'll describe the process, and then we'll continue in the remaining videos to figure out how we would do all of the machining for this part.